Assalamualaikum guys. Thank you so much for giving so much of love for my last video on 3D printing. 3D printing was one of the interesting one. Yes, if you haven't watched that video, please do check out the video at the I button present here. But in this video, we are going to learn about the derivation of equations of uniformly accelerated motion. We will try to derive three equations of kinematics. This concept is not only there in 9th class CBSE as a basic and 9th class state syllabus, but also covered as the 11th class basic concept. So do check out this video because this is going to be interesting again. Thank you so much. So without wasting much of our time, let's get started. So guys, welcome back. As I was talking about the uniformly accelerated motion equation, here these all equations referring to the body which is always moving in a constant acceleration. These equations will only work for the body which is having the equal rate of increase or decrease in the velocity. Let's have a look at these equations. These equations are velocity-time relation, position-time relation, and position-velocity relation. So let's now look at the second equation, which is position-time relation. That is S is equals to ut plus half at square. So we are looking at the second equation, which is position-time relation, generally referred as position-time relation PT. And here we can write the formula S is equals to ut plus half at square. S is equals to ut plus half at square. As we know, S is referring to the displacement and U is initial velocity, T is time, and A is acceleration. To solve this equation, we need to have a look at this graph. As I already told you that today's topic is extracting or deriving the equation through the graphs. So to solve this position and time relation, we need to have a look at the graph which is velocity time relation. Here the velocity is plotted on y-axis and time is plotted on x-axis. If you look at this graph closely, you will find that the velocity of the object is not starting from the point 0, it is starting from the point u. This means that the body is already moving with some initial velocity u. And if this body is continued for a period of time and it is observed that the velocity of the body has changed from u to v, so now the final velocity of the object at certain time t is v. So if you look at the graph, the velocity was starting initially at u and ending at final velocity v. That means velocity is continuously changing. So we have to first find the area under this graph. Area under the graph gives us the displacement covered by the object. So let's find the area under the graph. If you divide this area under this line into two, you will find that it's making up a rectangle and the top portion is making up a triangle. Alright? So if you calculate the total area of a rectangle and a triangle, then you will get the displacement. Let's write the formula of that. Area of a rectangle is L into B plus area of a triangle, right? So area of a triangle. Let's write here. We know that area of a rectangle, to find the displacement, is length into breadth. Here this length is nothing but time and breadth is nothing but u. So we should multiply u into t. So you will get u into t here. And we already know that the area of a triangle is the formula half into base into height, right? So I will write S, the u into t is as it is. So let's write it as ut, and plus I will write half, and half is half only. Okay, what is base? Here when we are talking about the triangle this, we should take the base which is this, which is again t. So I will write t here and into height of the triangle. So this height, how to find the height of the triangle here? Total length minus this length, you will get the length between here. So to get the height, you should subtract v minus u. So instead of height, I will write v minus u. So it is the time to check the equation we are getting is matching to the equation we want or not. If you look at here, S is there, okay, in our equation we wanted S, it is available. In our equation we wanted U and T, it's there. In our equation we wanted half, it's there. And now but we want acceleration. Here we have T but we don't have A, but we have an unwanted thing which is V minus U, so we have to remove them. How to remove this V minus U? Let's have a look whether we can have any relation from the first equation or not. If you see this first equation, V is equals to U plus AT. Alright, so we wanted to remove V and U, but we wanted to add A and T, which is here. Okay, so what do we do is, I'll send this U here. What happens? V minus, if U comes from that side, becomes minus. V minus U is nothing but AT. That means from this equation we can substitute V minus U as AT here. So instead of V minus U, I will put AT. So I will write S as it is, as we haven't done anything, UT as it is, and half as it is, but time is also as it is. Okay, V minus U, instead of that I will write AT. You should please follow me when I am saying, you can also repeat at your side, and when you're repeating it, you will surely getting it. Repeating it helps you in memorizing, and not only that, understanding, building understanding. When you're forcing your brain to indulge itself into the learning, then you will surely learn it. So repeating will make the brain to force and focus at one point. Please focus and please repeat. Okay. So okay, V is equals to UT plus half AT square. I will write S, and you know UT is UT, okay, and half is half only, okay, and this time multiplied to time, it becomes time square. And what is there remaining? A into T is AT square. You got the equation. S is equals to UT plus half AT square. We got the equation, second equation. Yes. थैंक यू सो मच गाइस, उम्मीद करता हूँ ये वीडियो आपको बहुत पसंद आया होगा। ऐसे इंटरेस्टिंग वीडियोस के लिए साइंस लेक्चर्स 9th to 12th और सीबीएसई स्टेट के लेक्चर्स, इंटरेस्टिंग प्रोजेक्ट्स आरसी प्लेन के लिए मेरे चैनल को सब्सक्राइब जरूर करिएगा। लाइक करना तो बनता है, बेल आइकन दबाए बिना जाना नहीं। That's it for today's class. Stay tuned to my channel Ambitious AB.